Hello, my name's George and welcome to this Medic Mind tutorial where today we'll be focusing on BMAT Section 1 and in particular those pesky problem solving questions and in this case date and time. Today I'll be guiding you through some of the key questions that we have collected over the years that demonstrate perfectly the tips that you should be employing when answering these questions. So without further ado, let's crack on. So the lesson objectives of today are threefold. First, we want to introduce you to the shortcuts involving date and time. These are sort of mental arithmetic you can do quickly to help you save time when answering questions. Second, we want to help you to use your working to answer questions. That means maximizing every resource at your disposal, including the paper and pen, highlighters, and any sort of writing that you can do to help plan your answer. And finally, we're going to be going through some worked examples, and we'll go on to those in a second. So date and time questions are questions which involve some sort of calculation with, you've guessed it, date and time. Now usually these involve a group of people who are doing things at different times or in different orders. For example, people might have their birthdays on different months of the year, or there might be a person who needs to work out some sort of schedule involving hours, minutes, days and weeks, etc. And that means it's important to be familiar with the key details with date and time. That means being familiar with how many minutes are in an hour, how many hours are in the day, as well as things like how many days are in a leap year, for example, as well as each individual month. So it's important to be as quick as you can with those sort of niche details. And finally, it's really key with these questions to use mental arithmetic whenever you can. Obviously, in the BMAT, you're not allowed a calculator, so you have to do all of the working on your own. So if you can speed up the amount of mental arithmetic you can do, you can minimize how much you write down and therefore save time on these questions. So let's go over some key facts to memorize. The first is how many hours, minutes and seconds are within a day, and you can see these on the screen now. Now, if I were you, I'd be prioritizing how many hours in a day, obviously, as well as how many minutes are in a day. How many seconds are in a day? This comes up more rarely, but if you're going to remember everything, you may as well remember this fact as well. It's also important to be familiar with how many days are in a year and how many days are in a leap year. So that's 365 normally, but 366 every 4 years, apart from millennial years. So apart from the year 2000, the year 1000, and again the year 3000. Finally, it's good to know which months have 31 days in them. And this includes January, March, May, July, August, October, and December. In contrast, the months with 30 days include April, June, September, and November. So a good little Medic Mind tip to help you remember which months of the year have 30 days and which months of the year have 31 days is to count it out on your knuckles. And we'll go through this together. So if you put out your knuckles like this and you start counting across, we see that January falls on the first knuckle. That means that it has 31 days. February falls in between the knuckle. That means that it has 30 days. March falls next on the knuckle, which means that it has 31 days. April falls in between the knuckles, 30 days. May on the knuckle, 31 days. June, again in between the knuckles, that means that it has 30 days. And July, which falls on the knuckle, that means that it has 31 days. So to recap, you count in between the knuckles and you have January, February, March, April, May, June, July. Now when you switch to the other knuckle, you carry on from the first knuckle. So we have August, that has 31 days. September has 30 days, remember. October, 31 days, because it has Halloween on the 31st day. November, that's 30 days. And finally, December, that's 31 days. And then we start back again at the beginning. So hopefully this little knuckle technique will help you to remember, or at least recap very quickly in the exam, which months have 30 days and which months have 31 days. So not only is it useful to know those statistics with regards to which months have 30 and which months have 31 days, it's also useful to employ some little shortcuts to help you speed up how fast you can answer these questions. Now, one of the ways you can do that is, for example, if a question asks you to look out for two dates that will fall on the same day of the week, then the number of weeks between those two dates must be a multiple of 7. So, for example, if we know that day 5 was a Wednesday, and we're asked what is day 13, we find the difference between these two dates, 13 take away 5 is 8, divide that by 7, we get 1 remainder 1. That means there's 1 week between these plus 1 day. So that means that if a 5th was a Wednesday, then the 13th will be a Thursday. And you can extrapolate that method up to large differences between dates. Likewise, if you have a situation where you're looking at months of the year and you're asked which two dates fall on the same month, then equally you can look at the number of months, so the 5th month of the year versus, let's say, the 24th month. You take the difference between the two, so in this case that's 19. You then divide by 12, so that's 1 remainder 7, and that means that you're 7 months on from where you started. So if the 5th was, let's say, October, you just count on 7 months from October. And that little tip can help when working out which months fall on the same month of the year. So let's go through an example of that. Here you can see a little question on the left and the answer options on the right. Pause the video now and have a go at this question. So let's go through this example together. If we look at the question, it's asking about which friends have the same birthday on the same day of the week. So we can highlight same day. That means that we can use one of those Medic Mind time saver tips to help us with this question. If we then look back at the question, we can see there's 4 different birthdays, and I'm just going to highlight them now in blue. That's what we're dealing with here. Now we could take each in turn and divide them by 7. That would give us a multiple of 7, remainder 1, 2, 3, all the way up to 6. And that remainder, if it's the same in 2 of those cases, then we know they're on the same day of the week because they're divisible by 7 and they have the same remainder, so therefore they will fall on the same day of the week. However, there's a quicker way to do this, and the quicker way is to realize that we're looking at the differences between the friends. So let's take an example. If we take Jack and Ni Young, the 114th as well as the 163rd birthday, and we find the difference. So in this case, let's do 163 minus 114, and that would give us 49. At this point, we have to question, is this a multiple of 7? If it is, that means that their birthdays fall on the same day of the week, because they're perfectly lined up at 7-day intervals. In this case, 49 is a multiple of 7, so we can be content in the fact that we've actually, on our first try, found the 2 friends which have their birthday on the same day of the week. So in this case, the answer is Jack and Ni Young, and we can give that a little tick there. Now, if we were unsure, we could go on and we could answer the question for the other friends. So for example, we could pick Jack and Sophie, Jack and Lisa, before then moving on to Ni Young and Sophie, Ni Young and Lisa, before finally doing Sophie and Lisa. And it's important that you get into the habit of looking at the question in a systematic way like that, so you never miss out any potential possibilities. Now, appreciated, that can be quite long, but ultimately part of the BMAT is trying to work out how long a question will take you, and therefore trying to employ any time-saving techniques you can. In this case, it might take you a fair bit of time, so if you were strapped for time, you might want to choose to move on to one of the critical thinking style questions, which tend to be a little bit quicker. But in this case, we can see that we fall across the answer on our first try, which is brilliant. So we can tick answer A and move on. Now, it's really important to remember that you don't have a calculator in the BMAT, and that puts a real premium on those people who have good mental math arithmetic skills. So one of the biggest tips we can give you is practice those skills. Even if it's as simple as writing out the times table and getting into the habit of learning them every single day, it can really speed up how quickly you can do these sums and therefore speed up how quickly you can do the questions. Other useful resources are free websites out there which help you to practice your mental maths. These include Sporkle as well as Elevate. So my recommendation would be to practice your mental math as much as possible, even if it's not on a particular question, just drilling yourself on times tables, before then looking at websites that can help speed up your mental maths, before then eventually going on to answer BMAT questions. Okay, so let's move on to question number 2. This is another date and time question, but slightly different, and in this case, slightly easier. So in the BMAT, if you can work out how quickly you can do a particular type of question, you can prioritize your time better and potentially answer this question in preference to the previous one if you're going through the BMAT. So pause the video now and have a go. Great, let's go through it together. So we're looking for how far apart are Julie and Mark's birthdays. And we're given information about the other pairings. So for example, we're given the information about Max and Julie as well as Mark and Jennifer's. So that means that we're going to have to work out potentially when everyone's birthdays are before then eventually finding out what's the difference between Julie and Mark. Now, whenever you've got this kind of situation where we're looking at months of the year and birthdays on particular months of the year, what I tend to do is write out those months of the year. Not in full, but just using their initials. So if we do that now, we have January, February, March, April, May, June, July, August, September, October, November, December. Okay, just like that. And you can do that on a scrap bit of paper in the exam. We then can visualize this information and plot it in a much more concise way. So we're told coincidentally their names begin with the first letter of the month they were born in. So that's useful information. So we know that Max is potentially either in March or May. Likewise, we know that Julie is either in January, June, or July. With Mark and Jennifer, it's exactly the same situation. So it will involve a bit of trial and error with this one. The important thing, though, is that Max, Mark, Julie, and Jennifer all start with the same sorts of letters, so it's really important that you be clear when you're writing down to avoid yourself getting confused. So let's take each bit in turn. We know that no one is born in January, so we can cross that out from the get-go. After that, we know that the friends are born on the same day. Their first letter of their name is the same as the first letter of the month that they were born in. So in this case, Max and Julie, let's take them. We're either dealing with March and May or June and July. And we have to maximize that so that they're 4 months apart. So using a bit of trial and error, we can say that actually Julie is over here in July and Max here is in March. Now moving on to the other pairing, we're looking at Mark and Jennifer, and we know that they're only 1 month apart. So again, using a bit of trial and error, we can apply that to this question and plot them on this little timeline of months. So let's do that. Okay, so hopefully you can see how those sort of pairings, and particularly those sort of pairings with the months, satisfy the rules that we were given. And we can always read back the question and just check that that's correct. But crucially, this one involves a bit of trial and error. And I always say with the BMAT, it's about being an educated trial and error. With Max and Julie, we know that they're 4 months apart, so we're trying to increase the spread as much as possible. So it makes sense to pick March and July. Likewise, with Mark and Jen, we're trying to minimize that distance, so it makes sense to pick May and June. Now we can answer the question, how far apart are Mark and Julie's birthdays? Well, in this case, you can see Mark is over here in May and Julie is in July. That means that they're 2 months apart. So the correct answer here is B. So a really good tip and something that came out of that last one is it's really important to get your notations down on paper because that allows you to visualize the question. Often the BMAT questions will be really wordy, and because they're problem solving, that wordiness can help you get confused. So it's really important that you write down the information that you can. Now in the last one, a common trap there was because they had such similar names, Max and Mark for example, it could be confusing if you just wrote the letters M. So in that case, write the full name out. Otherwise, if they were different names, it would be perfectly fine to write down their initials. So just make sure that you're writing down on paper and that you're doing it in the most clear way you can. And that'll save you time because you won't be fretting about where you've got confused with particular notations. So moving on to question 3 out of 6 with date and time. And this one is particularly looking at timings and a particular schedule. So pause the video now and have a go if you can. So let's go through this together then. So this question is about Mary Berry, which is great because everything to do with Mary Berry tends to be good. Now, we can highlight the important information. In this case, she's making 30 cookies. She's doing so in batches of 6. And that means that she's going to need 5 batches. And we can write that down because that's really important to this question. In between those two figures, we're given some information about the timings. So for example, she puts them in the oven for 20 minutes, and that's after a 30-minute preparation time. She then has to physically watch them for 5 minutes. Now this question isn't as easy as it first seems because it gives us this little piece of information here. She can work on the next batch. So let's put that in a nice little bracket there because that's really important to the question. So all in all, we're faced with the situation where we've got 5 batches of cookies, but these batches are going to overlap. And that means that we can't easily just add up the timings and then simply add it on to 2 p.m. We have to be a bit more clever. So if we think about the ways we can go about this question, if you're initially confused, my top tip for these types of questions is just to get stuck in. Imagine that you're doing the cooking. Guide yourself through batch 1, batch 2, batch 3. Hopefully, you won't have to go through all of the batches because hopefully by batch 1 and batch 2 and batch 3, you would have spotted some sort of repeating pattern because it makes sense. She's doing a repeated action. She's making cookies, she's putting them in the oven, she's starting cookies again. It's a repeated action. It would make sense that there's going to be some sort of pattern there. So my top tip, if you can't see the pattern, just get stuck in and see whether the pattern falls out of your working as you go. If not, then it's up to you to make the decision. Do you simply sack this question and move on, or do you persevere and just get it done because you've got plenty of time? Up to you. Now, if you didn't immediately see it, that's what I would suggest. However, if you quickly get to grasp with what this question wants, we can crucially get onto some time-saving tips. And my time-saving tip for this one would be let's treat it as normal, as if the batches aren't overlapping, and then take off the time that she saves by overlapping those batches. So, going through it, she takes 30 minutes to prepare, 20 minutes in the oven, and then a final 5 minutes where she's simply just watching the cookies because she's got nothing better to do. So, all in all, that means that we're dealing with 55 minutes per batch. Extrapolating that through, how much does it take us for 5 batches? Well, that's 5 times 55, and this is where it's good to be quick with your mental arithmetic. That gives us a nice answer of 275 minutes for the whole thing. Now, we said that was non-overlapping. Now let's consider the amount of time that she could save by overlapping her batches. Now the only part which is overlaps is this part in the oven. So she's saving 20 minutes each time because that's when she can work on the next batch. Now this isn't 20 times 5 because remember the first batch she can overlap with the second, third batch likewise, but the final batch she's just going to put in the oven and she's just going to have to wait for that. So actually we're doing 4 lots of 20 minutes saving. So if we work that through, we've got 4 batches where we could save time. We're saving 20 minutes each time. And that gives us a nice saving of 80 minutes when we do this multiplication through. So we have 275 minutes, take away the 80 minutes saving, and that gives us a nice answer of 195 minutes. So that's useful, and we're nearly done the question. The only thing left to do is convert that back into hours and then add it on to 2 p.m. So the quick calculators amongst you would divide that by 60 and you get 3 hours 15 minutes. We can then add that on to 2 p.m. and that gives us 5:15 as a finish time. All in all, that's answer A. So hopefully you saw in that last question that one of the first things we did was to highlight that she's got 30 cookies and she's making them in batches of 6. Now if you didn't spot that, you could become easily confused. So it's important to highlight the real key bits of information at the start. Likewise, if you remember, we highlighted in blue that little part where she said that she could overlap the batches because she could put one in the oven and then start work on the next batch. Now I've seen many students simply ignore that and just add it up without considering that overlap between the batches. And if you did that, you might get an answer which is listed in the answer options, but it won't be the correct one. So just make sure you read that passage thoroughly, and one of the ways you can do that is by bringing a highlighter in the exam, which you can do, and then using it to highlight the question. Okay, let's go on to question 4 out of 6. Pause the video now and have a go at this question. Okay, let's do this question together then. So we're told that Glynis has this clock and she notices at one point of time that actually we're dealing with cube numbers and zeros because Glynis is the most fun person you could happen to meet. Now she realizes that this won't happen again until January. And the question is, how many times in January will that occur? So let's work through it. Well, we know, first off, that this involves cube numbers. So let's just write them down. We have 1 cubed is 1, 2 cubed is 8, 3 cubed, 27, and 4 cubed, 64. Now if we stop there just for a moment and think ahead, if we're dealing with days of the month, as well as hours in the day, as well as minutes in the hour, actually we can see that 64 is out of bounds in all of those cases, so there's no point in carrying on. For example, there's not 64 days in the month, not 64 hours in the day, and not 64 minutes in the hour. So let's just scrub 64 off, because it doesn't make sense to keep it there. So the numbers we're dealing with is 1, 8, and 27, and we could go ahead and add 0 on there in blue, because we're also told we can have zeros. Now let's think about it. The 1st of January, we're only dealing with January, so we're going to be dealing with days of the month, hours in the day, and minutes of the hour. Now this can seem a bit overwhelming, so let's just start with one day of the month, the 1st of January, 0101. Now on the 1st of January, let's think through all of the times where that clock shows only cube numbers and zeros. We have 00, 00. We have 00, 01, 00, 08. Oops, apologies for that. 08, 00, 27. Those are all of the times for the hour 00. Now let's do the same thing for the hour 01. 01, 00, 01, 01, 01, 08, and 01, 27. Now let's do yet again the same thing with hour 8. Now at this point you might question, well, why couldn't we have, for example, 0818? Because that does also consist of cube numbers. Now, yes, that's true, and arguably the question is a bit ambiguous, but in this case, it's talking more about the minutes as a whole. So if you had 0818, that would be interpreted as 18, which isn't a cube number. So that's why these are the only combinations we can have. And remember, because there aren't 27 hours in the day, we can't carry on and do 27, we have to stop there. So on the 1st of January, these are all of the possible times that we can have. If we add them up, we can see that we have a total of 12. That's just on the 1st of January. So if we extrapolate forward, the 1st of January has 12, likewise the 8th of January will also have 12, and the 27th of January would also have 12. So we have 12 lots of 3. That gives us a grand total of 36 times in January, and that is the correct answer. And that's why correct answer here is E. So a common trap here is not being robust enough with the set of rules presented. There are often many premises under which the problem can be solved, so you have to really work out that you're addressing the rules in the question. In the last one, I appreciate the bit of ambiguity with what happens when you have, for example, 18 minutes. But if you think about it, that would open the door to a lot of confusion, so it's similar to keep it like it was and like we explained. So all in all, it's about being robust with the set of rules presented to you and carrying on and plowing through that question with some mental arithmetic and quick thinking. So, on that topic of robust rules, let's have a go at this question. Pause the video now and have a go. Let's go through this question together. So, we're given some information in the question about how this particular ward in a hospital labels its babies essentially. And it's a big long string of digits which all mean different things. The last digit is a verification digit, and that's the sum of the previous ones, particularly the unit value of that sum. The second last two digits, they represent the number of babies that were being born. So the 42nd baby ever born at the clinic in this example. The first few digits, therefore, the first three represent the month since the first baby was born, and then the following two represent the day of that month. So it seems like a legitimate reference system, and we just have to apply it to these numbers here, and in particular try and rule out 4 out of 5 of them. So the first thing and the easiest thing to do with these questions is to look at the verification digit at the end. Now often some of these answer options will have something wrong with that verification digit. So if we look at them, we can see that actually C, if we add it up, 1, 9, 5, 3, 1 and 5 and 0, adds up to 24. And that doesn't end in a 5, so we can just cross that one off straight off the bat. If we apply the same thing to E, we can also see 2 plus 0 plus 0 plus 3 plus 1 plus 2 plus 3 is 11, and that doesn't end in a 4, so we can cross that one off there. The remaining 3 are actually fine in terms of the verification digit, so we can leave them be for now. Now, obviously we don't know what particular number of baby was being born at the clinic, so that information isn't going to help us. What will help us though is the month that they were born in and the day of that month. Now, if you look at the remaining answer options, you can hopefully see that actually the day of that month is 31 in each case. Now that should ring alarm bells in your head because 31 days is actually a rare thing with months. Some months have 31 days, some months have 30 days. So my guess is that that's where the flaw in some of these reference numbers will lie. So how do we go about working out what month each of these babies are born in? Well, if we look back at the question, we can see that actually 157 corresponds to October. So if 157 is equal to October, we can then work out what these particular months are in the answer options. So we're given 3 answer options, 192, 194, and 196 for answers A, B, and D respectively. To work out what month they are, we can look at the difference between this 157 and each answer option in turn. So the difference between answer option A and 157 is 35. Divide that by 12 and you can almost see that 36 is a multiple of 12, so this is 1 backwards from a multiple of 12. In other words, 36 is in October, so actually 35 is in September. Doing the same with the other ones, we can see that 194 is actually 37 difference, and 196 is actually 39 difference. So again, if we apply that technique, 37 divided by 12, well, we know 36 is a multiple of 12, so 37 is remainder plus 1. So actually October plus 1 is November. And likewise, 39, that's plus 3, so October plus 3 is in January. Now if we look at this again, which months have 31 days? Well, September has 30 days, so we can cross that off. November has 30 days. We can cross that off. Remember our knuckle technique for working that out. And finally, January does have 31 days. So actually, This means that answer D is the correct one here because it falls on a month which does indeed have 31 days. The other two answer options, A and B, fall on months which don't have 31 days, therefore the reference doesn't make sense by saying that actually this baby was born on the 31st day of those months. That doesn't exist. So actually the correct answer here is D. Moving on to our final question of today then. This is question 6 out of 6. Pause the video now and have a go. Alright, let's go through it together. So, we're in a system where Alice is on Sunday and she has 14 tickets, or 14 stamps in this case. And we know that's Sunday the 3rd. Those are key bits of information. Now, if we think about how this system works, and one of my biggest tips would be to put yourself in the situation. We know that on Sunday, Alice will buy a drink, and then on Sunday night she'll be replenished 4 stamps. Now, given that eventually she's unable to get a drink, that means that the number of stamps required for a drink must be greater than 4. Why? Because if she goes a certain number down and then 4 back up, we can imagine a staircase will eventually it'll get down to 0 and she won't be able to afford a drink. But we're not told how much that drink is in stamps, so that should be our first point of call in terms of working out how much is that drink. Other key bits of information that we're told is that she works every day of the week apart from Saturday and Tuesday. Saturday and Tuesday. So, working that through. On Sunday the 3rd, and we know that she's unable to get a drink on the 10th. That's a total of 7 days. But it's not 7 days for Alice because remember she doesn't work on Tuesdays or Saturdays. So actually this we can erase out and actually she's dealing with 5 days. So if she gets 14 stamps, she has that on Sunday, she then goes through 5 days where she's paying out for a drink. So we have 5 days worth of X because we don't know what X is worth of paying out. But remember she's replenished 4 on each day that she works, so actually we can add on 4 lots of 5, so 20. And we know that that should be greater or less than the cost of a drink, because at the end of all of those 5 days she can't afford a drink. So actually we can set up this inequality here. Now, if we just sort of erase that through again and simplify it down, what we end up with is 34 minus 5x is less than x. Rearranging that, we end up with 34 is less than 6x, which gives an integer value of x of being 6. So we know that it costs 6 tokens, or 6 stamps in this case, to be able to buy a drink. That's really important. We've almost done half the question. We now just have to apply it through to work out, 1, how many stamps did she have on the 10th, and then extrapolate that forward to find out when's the next time she can't afford one. So, let's do that now. So if we imagine it, on the Sunday the 3rd, she has 14 stamps. She then spends 6 and then gets 4 back. So at the end of Sunday, and I'm going to use this notation, end of Sunday, we know that she has 14 minus 2 is the net loss, which gives us 12 stamps. On the Monday, the exact same thing happens. We go down 6, we gain back 4. So at the end of Monday, we're left with 10 stamps. Now on Tuesday, we're told she doesn't work. Wednesday, we go down to 8 stamps. End of Thursday, 6 stamps. You can see we're losing 2 each time. Friday, we're on 4 stamps. Saturday, we don't work. And Sunday, we've checked our answer because now we realize she can't afford that drink. She's only got 4 stamps at the end of Friday, 4 stamps therefore at the start of Sunday the 10th, and that means that she can't afford it on that day. So she doesn't buy a drink and she goes back up 4. So we end up with end of Sunday, we're on 8 stamps. We then carry that forward. So on Monday, she goes down 6, back up 4. So end of Monday, we're on 6. Tuesday, remember, she doesn't work. Wednesday, we're on 4 stamps at the end of the day, and this is the same situation. We're on 4 stamps at the end of Wednesday. That means on Thursday, she won't be able to afford her drink again. So the correct answer here, hopefully you got it, is Thursday, and that's correct answer is D. So what are your take-home points? Hopefully you've learned a few shortcuts about how to answer date and time questions. Remember, they involve using the mental arithmetic of, for example, how many days in a year, how many days in a leap year, as well as the different months of the year and whether they have 30 or 31 days. We also told you about time-saving techniques, such as dividing differences by 7 to find out whether they're on the same day of the week, or dividing differences by 12 to find out whether they're on the same month of the year. Second, we helped you to use working to answer questions, remembering to highlight key bits of text, as well as use your writing paper whenever you can. That can help you plot out and visualize the answer before you actually work out the problem. Third, we went through a load of worked examples, and hopefully you can see there are varying difficulty. That means one of the key skills of BMAT is to work out how long will this question take you. If it's relatively quick, then that's fine, you answer the question quickly. If it looks like it's going to take a bit longer, for example that Mary Berry question about the batches of cookies and the overlapping cooking times, if that looks like it's going to be long, then it might be worth considering moving on to the next question, which might be a bit easier. So that's our lesson complete. My name's George, and I hope you found that useful, and I look forward to seeing you again soon. Bye!